Ketones, organic chemistry. Contents. Here's what you'll find in this topic. Number 1. Short background, properties of ketones. Number 2. Functional groups of ketones. Number 3. Proper EUPAC or common naming. Number 4. Writing of structures. Number 5. Examples. Common or EUPAC names, the structures of ketones, and the uses of ketones. But first, what is a ketone? Ketone. Any of a class of organic compounds characterized by the presence of a carbonyl group in which the carbon atom is covalently bonded to an oxygen atom. Here is some short background of ketones. Ketones was first discovered in the urine of diabetic patients in the mid-19th century. For almost 50 years thereafter, they were thought to be abnormal and undesirable byproducts of incomplete fat oxidation. In the early 20th century, however, they were recognized as normal circulating metabolites produced by liver and readily utilized by extrahepatic tissues. Also, another short background of ketones is that ketone compounds have important physiological properties. They are found in several sugars and in compounds for medicinal use, including natural and synthetic steroid hormones. Molecules of the anti-inflammatory agent cortisone contain 3 ketone groups. The simplest ketone is this example. Its molecular formula is C3H6O. From this formula, we can say that for N carbon atoms, we need 2 N hydrogen atoms and an oxygen atom. Hence, general formula of ketone is CnH2nO. Now, let us tackle the properties of ketones. In ketones, a carbonyl group has 2 hydrocarbon groups attached. These can be either alkyl groups or another containing benzene rings. On those groups containing alkyl, ketones never have a hydrogen atom attached to the carbonyl group. Because ketones do not have hydrogen atom attached to their carbonyl, they are resistant to oxidation. Only very strong oxidizing agents such as potassium manganate or potassium permanganate solution oxidize ketones. However, this type of powerful oxidation occurs with cleavage, breaking carbon-to-carbon bonds and forming 2 carboxylic acids. Because of this destructive nature, this reaction is rarely used. The solubility in water. The small ketones are freely soluble in water, but solubility falls with chain length. The reason for this solubility is that, although ketones can't hydrogen bond with themselves, they can hydrogen bond with water molecules. The boiling point. Since hydrogen bonding is stronger than dipole-dipole interaction, ketones have lower boiling point than alcohols. However, the boiling point of ketones are higher than alkanes because dipole-dipole interactions are stronger along the dispersion forces. Now, here is the functional groups. A ketone is a functional group that consists of carbonyl carbon, which is a carbon atom bound to an oxygen atom by a double bond, and 2 alkyl or aryl groups. Alkyl groups are formed by the removal of attraction of a hydrogen atom from an alkane, whereas aryl groups are formed as a result of the removal or abstraction of a hydrogen atom from an aromatic ring. Ketones are generally represented as RCOR, where R and RR can be any alkyl or aryl group. The general formula of ketone is CnH2nO, where N denotes the number of atoms. Number 3. Proper EUPAC common naming. These are the proper EUPAC naming steps. Ketones. The EUPAC system of nomenclature assigns a characteristic suffix of 1 to ketones. A ketone carbonyl function may be located anywhere within a chain or ring, and its position is usually given by a location number. Chain numbering normally starts from the end nearest the carbonyl group. Very simple ketones such as propanone and phenylethanone do not require a locator number since there is only one possible site for a ketone carbonyl function. The common names for ketones are formed by naming both alkyl groups attached to the carbonyl, then adding the suffix ketone. The attached alkyl groups are arranged in the name alphabetically.
Writing of structures. Carbonyl groups define 2 related families of organic compounds, the aldehydes and the ketones. In a ketone, 2 carbon groups are attached to the carbonyl carbon atom. The following general formulas, in which R represents an alkyl group and AR stands for an aryl group, represent ketones. As text, a ketone is represented as structural forms. In ketones, the geometry around the carbon atom in the carbonyl group is trigonal planar. The carbon atom exhibits sp2 hybridization. Two of the sp2 orbitals of the carbon atom in the carbonyl group are used to form standard deviation bonds to the other carbon or hydrogen atoms in the molecule. The remaining sp2 hybrid orbital forms a standard deviation bond to the oxygen atom. The unhybridized p orbital on the carbon atom in the carbonyl group overlaps a p orbital on the oxygen atom to form the pi bond on the double bond. Like the carbonyl bond in carbon dioxide, the carbonyl bond of a carbonyl group is polar. Many of the reactions of aldehydes and ketones start with the reaction between a Lewis base and the carbon atom at the positive end of the polar carbonyl bond to yield an unstable intermediate that subsequently undergoes one or more structural rearrangements to form the final product. Example number 1. Acetone. The most important ketone is acetone, a liquid with a sweetish odor. Acetone is one of the few organic compounds that is infinitely soluble in water. It also dissolves many organic compounds. For this reason, and because of its low boiling point, which makes it easy to remove by evaporation when no longer wanted, it is one of the most important industrial solvents, being used in such products as paints, varnishes, resins, coatings, and nail polish removers. Number 2. Acetophenone. The acetophenone is a methyl ketone that is acetone in which one of the methyl groups has been replaced by a phenyl group. It has a role as a photosynthesizing agent, an animal metabolite, and a xenobiotic. Acetophenone is used for fragrance in soaps and perfumes, as a flavoring agent in foods, and as a solvent for plastics and resins. Number 3. Methyl ethyl ketone. Methyl ethyl ketone is a colorless liquid that has a sweet odor and is soluble in water. It is a highly volatile chemical and is frequently used as a commercial cleaner and solvent for glues, paints, coatings, and printing inks. Benzophenone. Benzophenone appears as white solid with a flowery odor, may float or sink in water. Benzophenone is used as an ultraviolet curing agent, flavor ingredient, fragrance enhancer, and perfume fixative, and is an additive for plastics, coatings, and adhesive formulations. Benzophenone is also used as a screen to prevent ultraviolet light-induced damage to cosmetics. Number 5 and last example, cyclohexanone. Cyclohexanone appears as a colorless to pale yellow liquid with a pleasant odor, less dense than water. In the industry, cyclohexanone is used as a solvent for lacquers, paints, resins, degreasers, spot removers, polymers, copolymers, waxes, crude rubber, cellulose acetate, the manufacturing of herbicides and antihistamines. In consumer uses, it is also primarily used in the production of nylon. Cyclohexanone is found in various consumer products, including in adhesives, paints, automotive, cleaning, and furnishing care products.
Uses of ketones. The most common ketone is acetone, which is an excellent solvent for a number of plastics and synthetic fibers. In the household, acetone is used as nail paint remover and paint thinner. In medicine, it is used in chemical peeling and for acne treatments. Methyl ethyl ketone, chemically butanone, is a common solvent. It is used in the production of textiles, varnishes, plastics, paint remover, paraffin wax, and etc. Methyl ethyl ketone is also used as a welding agent for plastics due to its dissolving properties. Classes of ketones. Ketones are classified on the basis of their substituent. One broad classification subdivides ketones into symmetrical and unsymmetrical derivatives depending on the equivalency of the two organic substituents attached to the carbonyl center. Acetone and benzophenone are symmetrical ketones. Acetophenone is unsymmetrical ketone. Fun facts about ketones. Ketones can be detected by smell. The ketone called acetone or nail polish remover is removed through the lungs. A person with ketones may have a sweet fruity odor to their breath. The acid load on their body may also make them take longer, deeper breaths in an attempt to remove ketone faster. This is called small breathing, after the doctor who first described it. Ketones are themselves an energy source for human tissue. The brain can use ketones during periods of fasting or starvation.